Composite functions. In this video, our objective is fairly straightforward. We want to form composite functions. Probably means we need to define what a composite function is. We'll get there. We know what a function is. A function is a relation in which each component of the domain is the set of all input values or x values, corresponds to exactly one component of the range, the set of all output values or y values. So now let's define that composite function term. A composite function is a function made of other functions. And we're going to be dealing with two, where the output of one is the input of the other. So we're going to run a number through a function, get an output, and then run that output through the next function. Okay, I'll show you some diagrams of that, and we'll look at some different ways of writing it as well. Not necessarily the easiest of concepts, but I'll break it down as best I can. So here's an example. The functions 2x plus 3 and x squared, two functions, together make the composite function 2x plus 3 squared. The x will first run through the 2x plus 3. So we'll do the 2x plus 3 first. We'll get the answer to that, and then we're going to square it. So the second function says to please square the answer of the first function. So here we are in a visual. The x goes in, 2 times input plus 3, and out comes 2x plus 3. Now this is the new input, and it goes into here. Here's the input. So we 2x plus 3 squared, and out comes 2x plus 3, the quantity squared like that. So a nice visual. Okay, let's keep going. I know this takes a little bit of time, and I'll show you some other ways of visualizing it, and then we'll do some examples. Function composition is basically applying one function to the results of another. We applied this function to the results of this function. In other words, you apply the first function, this one, you get an answer. You then apply this answer to the second function, and you get the final answer. So that it will go into the f function, for example. It'll come out of the x function with an output. That will go into the g function, and then you'll come out with the final result. Okay, in this case, the f function is done first. The result of f is then sent through g. How do we write this? Well, you can either write it as g of f of x. It's an open circle. It's not a times sign. It's not a degree symbol. It's an open circle. So here is g of f of x. Okay. So that's how you say it. I think I have a note on how you say it. I don't think I have a note. We say it as g of f of x. Like that. So g of f of x. Same thing here. G of f of x. Okay. These are the same thing. You can write it this way with this circle. Or you can write g parenthesis f of x parenthesis at the end here. Notice in this case, okay, the next two function, and I know I kind of made that up. The f is the next to the x function, goes first. And in this case, the inside function, losing my lead, sorry about that, goes first. So it depends upon how you write it. I don't know. I think this is the most common way of writing it, but you'll see this one as well. Okay, so g of f of x, g of f of x. Okay. And again, in this case, this with the g being the furthest away from the x, the f function goes through first. With f being the inside function, again, the f function goes first. However, hang on a moment here. However, you can also have the functions be flip-flopped. So here's another in writing. The composition of the function f with g is denoted f of g. Okay, f of g. And is defined by the equation f of g of x is equal to f of g of x. In this example, the g function goes first. Okay, in this example, we did the f function first and then the g. Down here, because the g is the next to function and the g is the inside function, the g function goes first. Okay, let's do one more look at it. And let's use a picture of kind of like a function machine. Let's illustrate it with like a function machine, and then we'll do some numerical examples. Okay, so here we have f of g of x, or f of g of x, and it's illustrated below. Again, the inside function in this case, or the next to function in this case, goes first. In this case, it's the g function. So your input value goes into the f function, and out comes a result. That new result now goes into the f function, and out comes your final result. Okay, so it has to pass through two machines to get to the final result, one after the other. Okay, how about some numerical examples, which I think will help, or some mathematical examples, which I think will help us make sense of it. We're given two functions, f of x equals 3x minus 4, and g of x equals x squared minus 2x plus 6. We want to find f of g of x. So our g function is going to go first. Okay, I'm going to note f of g of x is the same thing as f of g of x. Okay, so here, the next to function goes first, or the inside function goes first. So what is g of x? I'm going to do that first. G of x is x squared minus 2x plus 6. Okay, that one's done. X went in. What came out was x squared minus 2x plus 6. Done. Let's go back to our machine here. We put x in, and out came x squared minus 2x plus 6. Okay, now we're going to take the f, we're going to put this into the f function. The f function says, you give me the input. Here's the f function. Whoops, you can't see that. There we go. The input is here. I will multiply it by 3, and then I will subtract 4. Well, the input is the g function in this case, right? That's the input, is the g function. So I'll put the g function in here, and then I'll subtract 4. Well, what is the g function? The g function is this. So I'll put the g function in here, 3 times x squared minus 2x plus 6. The f function says take the g function, multiply it by 3. I just did that, and then subtract 4. Okay, we'll do my multiplication, distribution, 3x squared minus 6x plus 18 minus 4. I will then combine like terms. In this case, it's just the two constants over here. And the final output is 3x squared minus 6x plus 14. And this is f of g of x right there. So the x went through the g function first, and out came x squared minus 2x plus 6. And then that result went into the f function, and out came 3x squared minus 6x plus 14. Let's take a peek. Let's say, what is f of g of 2? Well, I know what f of g of x is. Now just put 2 in for x. It would be 3 times 2 squared minus 6 times 2 plus 14. Let's see, what is that? This is 412 minus 12. I wasn't expecting that. This is 12 minus 12 plus 14. And so f of g of 2, if I run the number 2, whoops, I'm sorry. Let's go back. I keep forgetting. Make sure you can see what I'm doing. What is f of g of 2? Well, this is f of g of x. I'll put 2 in for x. I put 2 here and here. And I'll just do the math, and out came 14. So, if I run 2, I need to get enough space here, through the g function first, I'll get an output. If I then run that output through the f function, let's see, 2, this is 4 minus 4, I get 6. I run 6 through this one, 3 times 6 is 18 minus 4, and out comes 14. Okay, let's do a couple of more examples. Give me a moment to get my sheet together. Oh, I want to first copy down. I got my sheet, but I want to use the same 2 functions. So I'm going to write those 2 functions at the top of my sheet. F of x equals 3x minus 4, and g of x equals x squared minus 2x plus 6. Okay. In example B here, part 2 if you will, I want to do the f function first and then the g function second. Okay, so again, this is the same thing. I could also write it this way. The inside function goes first, the outside function goes second, the next to function goes first, the away from function goes second. So what is f of x? That goes first, x goes in, and out comes 3x minus 4. Done. Now I want to put this into the g function. I want to put this into the g function here. So g of input, the g function says, whatever you give me, I want to square it. I want to subtract 2 times it. And I want to add 6. Okay, so what is g of f of x? Well, f of x is 3x minus 4. So I'll put 3x minus 4 here for the input. I'll put 3x minus 4 here for the input, and then I'll add 6. And now it's just a matter of doing some math. Okay, I did not write all this out. We could expand this first, but I have the answer. This is 9x squared. You might want to expand that first before you multiply so you can see it. Minus 24x plus 16. I'll then distribute. Minus 6x plus 8 plus 6. And now I'll combine like terms. My answer is a quadratic. 9x squared minus 30x, I think. Yep. And then 16 plus 8 plus 6 is 30. So this is g of f of x. Now notice, this is not the same thing as f of g of x. Rarely, if ever, does f of g of x equal g of f of x. So let's make that as a note. F of g of x rarely, if ever, equals g of f of x. They will be different. Okay, so don't just say, oh, just the same thing, right? Nope, not the same thing. Doing the g function first and the f function second, I can't think of an example, but there might be one. So I would say almost never equals doing the f function first and the g function second. Okay, let's do another example. And this time, I'm going to run the f function through the f function. I'm going to do the f function twice. Okay, so this, of course, is the same as f of x. We can do this. Run x through the f function, and then run that output back through the f function again. Okay, let's remember, f of x is equal to 3x minus 4. Okay, now we're going to run again. We have f of x. So f of input equals 3 times the input minus 4. Well, the input is f of x. That's our goal. Well, this is f of x, 3x minus 4 here. So 3 times 3x minus 4 minus 4. F of x is 3x minus 4, so I put it in here, 3x minus 4, which means it goes here, 3x minus 4. And f of, well, I got ahead of myself, sorry about that. Let's simplify this right side, 9x minus 12 minus 4, and the right side is 9x minus 16. So f of x is equal to 9x minus 16. Let's do what we did on the previous page. We found f of x. It's this. What is f of 2? Well, let's check it here first. Let's run 2 through the f function. 6 minus 4 is 2. Let's run 2 again through the f function. 6 minus 4 is 2. Out comes 2. Okay, I ran 2 through it, I got 2. I ran 2 back through it, I got 2 again. So I should get the same thing from this. So let's see, this is equal to, remember f of 2 is 9 times 2 minus 16, which gives me 18 minus 16, and I get the 2 that I thought I would get using the composite function f of x. So those are composite functions, running a number or a variable through one function and then running the output through a second function.